Okay, 1.4 is all about algebraic expressions. Algebraic referring to the use of variables, adding and subtracting, and expressions meaning like math phrases, like 5x plus 1. Okay, so we're writing math phrases with variables. What we're trying to do is we're trying to translate words into those math expressions, or algebraic expressions. And then we're talking a little bit about how to simplify these expressions, okay? That's what 1.4 is going to be all about. Couple things, there are some key words for translating that you're going to see. For addition, you might see words like combine, plus, more than, some. Okay? Those words clue you in that you will be adding. Okay? For subtraction, you might see separate or separate, verb or adjective. Minus, right? Plus and minus go together. Less or less than. And difference. Okay? Multiplication. You might see combine into equal groups. And that's a rare one. You might see it. You're more likely to see times. My favorite is of, and of course product. Last one, division, separate into equal groups. That one's pretty common. If you have to separate things into equal groups, you're dividing them up, right? If you have to separate these cookies into 5 equal groups, you're going to divide by 5. Okay? Per is another one. And then quotient. Talked a little bit about quotient when we did rational numbers. Some keywords here. Sum, answer to addition. Difference, answer for subtraction. Product, answer to multiplication. Quotient, answer for division. Some things you should know. Okay? Couple examples real quick. Okay, so 2 quick examples. Age Y years after your 18th birthday. Okay, so the variable you're going to use is Y. And you see the word after. That means how many years more after you've turned 18. Okay, so you're going to take 18 and your age will be that whatever Y. 7 years after you should be 25. Okay, the number of days it will take to walk 200 miles, walking M miles per day. There's that word per. You're walking 200 miles. 200 miles per means divide. Per M days. Divided by M days. Miles per day. Like miles per hour. 200 miles per hour. That's terrible. Don't ever do that. But that's that idea of per. Okay, so these words clue you into how you want to treat different problems. Take the words, write algebra. Words say age Y years after 18. Algebra says 18 plus Y. Words, algebra. Okay, so now we're going to talk a little bit about how we simplify these things. A couple different things we're going to talk about. One is like terms, the other is PEMDAS. You all know what PEMDAS is. You don't even probably need to write this down. Okay, please excuse my dear Aunt Sally. Okay, parentheses, exponents, multiplication, multiply, divide. Aunt is addition. Sally equals subtraction, right? Okay, so you're going to do those operations in that order. Okay. 2 quick examples for you to try. Here we go. Every time you do an evaluation problem like these 2 that you're going to try right now, you need to start or substitute with parentheses. Okay? Start by substituting with parentheses. So what I mean is this 3x is 3 times 2. Put parentheses there. 7 times y, where y is negative 4. Okay, so then you're going to get 6 plus a negative 28 equals negative 22. That's the evaluation you're going to do. Okay, you try the second one. Use parentheses. It will make it easier. Okay, so looking at these right here, in that bottom one, when you gave it a try, those parentheses hopefully helped you keep track that you're going to minus negative 3. Okay, but order of operations not too tough. I know you know what you're doing. we could have thrown a square right here, and you would have still done just fine. Because now it's 3 times 4, and you would have been fine. Okay, the parentheses, exponents, multiply, divide, add, subtract. You all know PEMDAS. What might be a little bit tougher, is the last part. The like terms. Okay, like terms. Terms are things that are being added or subtracted. Like terms are terms, those things being added or subtracted, that have the same variables raised to the same exponent. Okay, a couple examples. Let's make a little list. We got some like terms, not like terms. X squared, 3x squared, negative 2x squared, all like terms. Fantastic. Okay? xy, 7xy, negative 2xy. 7, 11, 15. Half, pi. All numbers are like terms. Okay, some things that are not like terms. X squared and, x squared and 2x. Yeah, they both have a 2 with an x, but they're different. Okay? X squared y and y squared x. Not the same. The variables are different. The variables have different exponents, right? X squared versus y squared. Okay? Not like terms. Those are not like terms. Okay? What we can do is we can collect our like terms. Okay? We gather them all up. We put them all together. Up here, if we collect all of these like terms, we have a 1x squared with a 3x squared. That's 4x squared. Then we take away 2x squared. If we collect these, we get 2x squared. Down here, be 6xy. Over here, oh boy, 33 and a half plus pi. Kind of a strange one, but we can collect them. They're fine. You can even turn pi into a decimal and add that on too. We cannot collect like terms. Please never collect like terms. We'll call them unlike terms. Or dislike. No, we'll say unlike. Don't collect them. You can't put x squared and 2x together. Don't even try to put x squared and 2x together. Another two things that are not like terms that I would never want to see you put together are x and 7. X and 7 are not 7x. Okay? To give you a little bit of practice with these, I'll put two examples up here. You give them a try. Here we go. Oops, I should be careful. Okay, there's the first one. Two of them for you to try. Make it happen real quick. Collect those like terms. Might have to use the distributive property. Okay, how'd you do? Let's check real quick. You may want to get out a pen or something to mark them. This x squared right here. Oh, that's not going to work. Ew. Okay, here we go. X squared is like terms with 3x squared, right? They each have an x squared. That's our 4x squared. y is like terms with 7y. That's 8y's. And then that 2, not like terms with anything. Boo. Okay? That's okay, though. Let's do the bottom one. Distributive property. Distribute that -3. -6x plus 3xy minus 9y minus 11xy. Now you're ready to collect. Can't do like terms until you've done the distributive property. -6x is not like terms with anything. 3xy is like terms with minus 11xy. Minus 8xy. Minus 9y, not special. Or maybe it is special, I don't know. But it doesn't have any like terms. Okay, so our final answer looks like that. Lots of negatives in that one. That's kind of a letdown. Okay, but lots of negatives, not necessarily a bad thing. Just whatever. Okay? Final thought for you. When you collect your like terms, LTs, not Lidanian and Tomlinson, just your like terms. When you collect like terms, the answer, the result, the collection. The result is another like term. Here is what I mean. Try this one more time. Okay. Let's look at the like terms we collected in that first one. X squared, 3x squared, those were our like terms. The answer was 4x squared, not 4x to the 4th. Okay? Not 4x to the 4th. Let me grab a different color. We'll grab that purpley thing. Another one. 3xy. Negative 11xy. The answer is a like term, that negative 8xy. The x and the y stay the same. So when you collect like terms, you get a like term. Okay? So, how do we write them? Well, we talked about translating using those key words. How do we simplify them? With either order of operations, some PEMDAS, or by collecting our like terms. That's kind of the key for working in an expression. Notice there's no equal sign. You're not solving for anything necessarily. You're just going to evaluate and simplify. Okay? So that's 1-4.